Okay, let's say a few words about inverses, and then we'll talk about how to take the derivative of inverse and find out it's really not too bad. It's just a series of little steps here, just like anything. First of all, well, let's just take a look at an example here. Let's see if we can take a look at maybe y equals x squared plus 1. And if we graph that, it would, of course, look something like this, right? And just for simplicity's sake, let's just take a look at everything on the left side. So let's take and erase this half of the graph, even though it's still there. All right. So let's write down what we have here so we don't forget. So we have, in red, we have y equals x squared plus 1. And then in this purple color, we'll do the inverse. Okay. Well, if you remember on the inverses, the x's and y's are switched, right? So if we have a purple function and we have a red function, to find the inverse of it, you just switch this y, this x, right? So they become, that's the relationship that they share. So let's take a look, of course, let's just take the first point here in red, which would be 0, 1. That's this dot right here, right? Well, the inverse in purple would be 1, 0, right? Which is right here. And then if we were to, say, pick another point on red, let's say when x equals, I don't know, x equals 2. You plug in 2, you get 4. 2 squared is 4, plus 1 is 5. So you have over 2 and up 5. And then you'll see that the inverse in purple would be 5, 2, right? So we go over here 1, 2, 3, 4, 5, and then up 2, something like this, right? So, and of course, if you remember from algebra, pre-cal, whatever, to find the inverse of a function, all you do is switch the x's and y's. So let's do that in purple. So to find the inverse, x would equal y squared plus 1. And then all we're going to do is solve for y, right? So see if we can do a little arranging on this formula here. We'd have x minus 1 equals y squared. Take the square root of both sides, and you get y is equal to plus and minus, which you'll see in a second. Now that's important. X minus 1. X minus 1. So this square root function, if you recall, graphically would look like what? Something like this, right? So let's take a look at what that looks like on the graph here. And really, once you see this once or twice, you'll remember. So this leg would look like this, and it will go something like this. All right. Now, the interesting thing about inverse is that it's not really necessary to remember this all the time, but let's erase some of this and get some more places to work here. Let's see here. So the nice thing about inverses, once again, is that if the inverses are, say, f and g, right? So f is the inverse of g, and you can also say g is the inverse of f, right? It's just like saying, you know, Joe is my cousin, and then you saying, or Joe saying, oh, Fred is my cousin, and your name is Fred, so it's no big deal. You still share the same relationship. Well, if numerically, if two functions are inverses of each other, the composite f of g of x is always equal to the letter x. Okay? And similarly, also, you've got the fact that, let's see, you also have the fact that g composed of f and x is also equal to what? Just 1x, right? So those two facts right there are going to help us when we take the derivative. Okay, well, let's see what this really means. Let me just hone in on this fact right here. If you think about the letter x, if you were to graph just x, what would it be? Let's do this one in green. If we did that, it would just be a straight line that goes right up here, right? 45-degree angle. And then it would come down here into this quadrant as well. Well, let's take a look at the relationship between do orange, between these two cousin dots. See the red dot and this purple dot. If you connect those two, and if you connect these two cousin points, we'll call them, these are the inverses. A couple things happen, and you probably remember this. If you draw this properly, these makes right angles. The intersection of the line y equals x and these two secant lines. Also, if you draw it properly, they're equal distance between there. In other words, that green line splits it right down the middle. And so anyway, that's kind of interesting. But the most important thing to remember on inverses is that the x's and the y's switch. Okay, so this video is getting a little bit lengthy. What I'd like to do is take the derivative, just the theoretical derivative of this inverse, and then make another video doing a couple of the homework assignments. Okay? Alright, so let's see if we can erase a bunch of stuff here. Actually, let's see if we can make a new page here. That's not it. Can't remember anything. Let's just erase it quicker. There we go. Alright, so this is going to be pretty easy since you understand the basics of these inverses. So let's say that you have the fact that f of g of x, you made a composite function, right? F of g of x, right? And because of its very nature, it's an inverse, it's equal to x, right? So let's take the derivative, all right? Well, what is the derivative? The derivative of just straight up x. That's equal to 1, right? Okay, so what is the right-hand side of our equation equal to? The derivative of x is just 1. Okay? Now, this next part becomes a little bit trickier because we have to use the chain rule. And everybody remembers the chain rule. So the big picture of f of g of x is that you have this value, that you have this function f, which is built on g of x, right? So the chain rule says take the derivative of f and don't touch the inside part, which is the g of x, right? But to that, you have to multiply it by the derivative of the inside stuff, which is just g of x. Okay? Okay. So here we have the derivative f of g of x times g prime of x equals 1. Alright? So it doesn't matter how you slice this up. If you were to solve for f prime of x, this guy right here, all you have to do is divide out 1 over g prime of x, right? And then you're left with, so this guy right here is gone, right? You basically just divide it by g prime of x on the left and the right, and then you would have f prime of g of x, and that's equal to 1 over g prime of x. 1 over g prime of x. So, what can we say about this here? Well, this g of x is just a fancy way of saying y, isn't it? So we could say that f prime of the y value, and this over here is in terms of x already, right? G, the derivative of x, so 1 over g prime of x. So basically, I'll show you in the next video by doing a couple of examples, but really all we're going to do is take the derivative of the original function, right? And then make the reciprocal of that, and then we're going to simply switch the x's and y values, and then it's a piece of cake. Okay, hopefully this little background helps a little bit, and we'll meet up again in another video. Thanks.